We intuitively treat animal behaviors as communicative, yet formalizing what makes them so reveals deep theoretical inconsistencies. Philosophers often use Ludwig Wittgenstein's concept of family resemblance to explain this difficulty. Family resemblance suggests that items in a category may be connected by overlapping similarities rather than a single, universal defining feature. Biological accounts define communicative signals strictly as products of natural selection, acts that evolved specifically because they alter a receiver's behavior. Informational accounts are broader, viewing communication as a statistical process where a signal simply reduces uncertainty about a state of the world. Intentional or Gricean accounts set a higher bar, requiring that communicative acts be produced with a specific set of nested intentions. This often involves a fourth-order meta-representational load. Meta-representation is the capacity to represent the mental states of others within one's own mind. For example, intending that a hearer recognizes your intention to change their belief. To find the origins of human language, we must deconstruct communication into its component subsystems: semantics, syntax, and pragmatics. By testing animal data against each layer, we can see where the human lineage diverged. This approach shows that animal communication functions as a distinct architecture with its own internal logic, rather than a precursor to human speech. We can analyze these systems using a cognitive stack. This framework allows us to evaluate animal behavior across 4 distinct axes. Semantics is the study of meaning, or the specific information carried by individual signs. Syntax refers to the ability to combine those units into larger, hierarchically structured strings. Pragmatics looks at how signs are interpreted based on the specific context of their use. Finally, cooperation examines the motivational foundation, the reason why an animal chooses to share or manipulate information in the first place. Using this stack helps us move past the booster versus scoffer deadlock, the tendency to either overhumanize animals or dismiss their behavior as simple reflex. In the semantics slot, we look for functional reference. These are animal signals that provide specific information about objects or events in the environment, much like words. The vervet monkey's alarm call system is a classic example. They produce acoustically distinct calls for leopards, eagles, and snakes, each triggering a specific escape strategy from the rest of the group. Critics argue that because these calls are sometimes given to non-threats, like a falling tree, they aren't truly stimulus-specific. If the signal isn't exclusive to the predator, does it actually refer to it? Informational accounts respond that reference only requires a statistical reduction of uncertainty. In this matrix, the eagle alarm call carries information because its presence makes the presence of an eagle significantly more likely than its absence, even if the correlation isn't perfect. Human language actually works similarly with indexicals. Indexicals are terms like this, here, or there, or even now, which lack fixed meaning and depend entirely on context. Despite this, we still consider them referential. While animals may not have human-like concepts for words, they use robust semantic systems to coordinate with their environment. Moving to syntax, we distinguish between simple combinations of sounds and hierarchical nesting. Japanese tits use an ABCD mobbing call, where the meaning of the whole depends on the parts. This is compositional syntax. However, evidence suggests this is a linear sequence rather than a nested hierarchy. Human grammar relies on an operation called merge. Merge is the recursive ability to take 2 objects, like words, and bind them into a single, hierarchically organized thought. This creates a structure where one unit can modify another subunit deep within a sentence. Studies of enculturated apes like Nim Chimpsky provide a look at the limits of animal syntax. While these apes can learn to produce strings of signs, their combinations remain limited. Research shows that while apes can track linear order, knowing the difference between oil in tomato and tomato in oil, they struggle with nonlinear structures. They appear unable to represent relationships like binding 2 nouns to the same verb simultaneously. Animals can execute linear communicative sequences, but hierarchical merge marks a significant difference in how humans process information. If animals possess limited syntax, they often navigate social complexity through the pragmatic slot, offloading cognitive work onto their surroundings. In Carnapian pragmatics, receivers use contextual cues to disambiguate signals. A monkey hearing a hack call will look for an eagle if it hears it in one context, but ignore it if the environment provides other cues, like a falling tree. Philosopher Dorrit Ba'an describes animal signals as Janus-faced. They are expressive behaviors that simultaneously show an animal's internal state and the external object causing it. When an observer sees a chimpanzee's fearful posture and gaze directed at a snake, the observer learns about the danger directly. This allows for complex coordination without the need for high-level meta-representation. Animal systems are heavily reliant on pragmatics, using the shared environment to provide the complexity that their syntax does not. The final axis is cooperation. Here, we ask if animals communicate to share information or to manipulate others. Cognitive scientist Michael Tomasello argues that animal communication is almost entirely directive, requests or orders for the benefit of the sender. He contrasts this with shared intentionality, where humans communicate specifically to help others. Recent data on wild chimpanzees complicates this. Chimps have been observed calling to warn ignorant group members about hidden snakes, suggesting that pro-social motivations exist in other primates. Attention is a key factor here. Species that regularly attend to humans, like domesticated dogs or the African gray parrot Alex, show a higher aptitude for understanding helpful communicative acts. This suggests that a high level of social cooperation likely drives the evolution of more sophisticated pragmatic interpretation. Reviewing the stack reveals that the differences between human and animal systems lie in specific architectural choices, primarily hierarchical syntax and the degree of cooperative motivation. One model of language evolution suggests that as cooperative attention increased in early humans, it may have provided the pressure for our pragmatics-heavy systems to develop more complex hierarchical organization. Evaluating the animal mind requires us to analyze its context-driven logic as an effective system for their specific needs, rather than a failure to reach our own.